So question number 53 for chapter 6 homework states that an 80-kilogram man is standing erect and he steps off a 3-meter high diving platform and begins to fall from rest. The man again comes to rest 2 seconds after reaching the water. What average force did that water exert on him? So the first thing we're trying to find is, we're trying to find the average force the water exerted on the man. So first, using the sum of forces, you can simplify your equation to get 1/2 mv squared equals mgh. And since there's mass in both equations, we can just get rid of it and simplify the equation as so. So we get 1/2 v velocity squared equals gh. And here we're trying to find the man's speed right before he hits the water. So we're trying to isolate velocity. And by doing so, you can plug in your known values. You plug in 9.8 meters per second for gravity and 3 meters for height, and you should get 7.661 meters per second. I forgot to write the unit, but that's meters per second. And so after that, this chapter, we learned that the linear momentum of an object moving is equal to the impulse, and by further simplifying this equation, we get force times time equals mass times velocity. And here we want to find the force of the man on the water, so we're going to isolate force to get this equation. And then once we get this equation, we can plug in our known values, and we get 306.724 newtons, which can be rounded to 307 newtons. So after that, this is my dog. So after that, we can use the sum of forces to find the average force of H2O on the water. So, Sesame, please go away. Okay, she just wants the spoon, so we can have her take the ladle. So we can use the sum of forces to determine that force is equal to ma, and since this is marked as positive, we have 307 newtons plus the force of the water equals mass 80 kilograms times acceleration. And by doing that, we get 784 as this value and 307 right here. But to find the force of the water, we subtract 307 newtons. Okay, I'm sorry, I decided to refilm this part just because I realized I was wrong, and also because my dog was playing all over the paper. So right here we have a negative 9.8 meters per second as our acceleration, and by multiplying this together we get a negative numbers, so we get negative 784, and to find the force of the water, we subtract 307 from this side, and we get right here, and we should have 1,091 newtons exerted on the man of the water as the force of the water, and that is our final answer.